the machine learning concept, we are starting with our linear regression. So now in this topic we are going to discuss about the supervised learning and reading the data, and we are going to plot the linear regression by using a seed-born to evaluate the model. Then we are going ahead with forming the linear regression. So now we are going to handle the data which is called advertisement data. So which is used to predict what kind of advertisement will give the more efficient value. So we have two types of supervised learning. One is classification and another one is regression. So this classification which is used to predict the categorical response, and the regression which is used to predict continuous response. So this categorical response we are going ahead with logistic, and this continuous response we are going ahead with our linear regression. So here the first step, we need to import our pandas in the name of whatever. Now I am just giving PD. So now I am just saving this data set in the same path where my file is saved. So I am creating another variable name. Let's have this as a variable name as a data. So pandas dot read underscore CSV. My data name is advertising dot CSV. Yeah, we need to give with quotes, and it's a case sensitive. So yeah, great. Now our data is read by pandas. Now I want to get the sample. So we have something like unnamed 0, like data like this, then TV, radio, newspaper, sales. So here in this data frame, actually this is a actual index, and we are having the peoples who are watching the TV and radio ad and the newspaper and the sales of the particular element. So now we need to start to analyze the data. So the first thing is, let's get the shape. What is the total shape of this data? So it's having a 200 rows and 5 columns. So this columns which already include our indexing. So now what are the features of this data? So this TV, that's nothing but we are just advertising how much dollar we are spent on TV, to advertisement in TV. Dollars actually in TV column we gave in the 1000. So radio, advertising dollars spent on radio, this much, and in newspaper advertising dollars we spent this much. So now what is the response when we are giving this much of advertisement in TV, radio and a newspaper? What is the response? So that's what our sales is. So what else do we know? Because the response variable is continuous, we are just having this continuous data, so we chosen a regression problem. So here we have 200 observation, that is nothing but the row. Each observation is our actually single market. So now the first step, I am planning to make a pair plot to analyze how my statistical data is in my statistical data of my linear regression. So the first thing, I am importing my seed-born in the name of SNS. So we are just implementing this. Then I am just giving my magical function of matplotlib inline. Yeah, it's also done. So the next thing is, we are going to make a pair plot. So why we are making a pair plot is, I want to visualize the relationship between the futures and the response, and I want to make this is in a scatter plot. The produced pair of a scatter plot which is used to analyze the relationship. So we are going to use the regression plot to plot the linear regression line. So I am just giving a seed-born pair plot, and we are going to do the seed-born pair plot for the data. And now what are the x variables I am planning to use, that we need to define. So I am defining x variables equal to, in a list I am giving. So here I am choosing a x variable as a TV, and x variable as radio, and I am choosing x variable as newspaper. Yeah, yes, so newspaper. Great, we done. So it's all case sensitive, so I'm just giving everything like my data. So the next thing what again I'm just going to do is nothing but I'm planning to give my y variables. To make y variables, I am giving the variable name of y vars, and then I am giving okay, it's a single data, so there is no need of list, so sales. So this is my y variable. Now I am just giving, I want to make the particular size, so I am just giving size equal to 7, and then I want to give some aspect ratio to control the size of the graph. So I am just giving aspect equal to 0.7, and then kind, which is used to make what kind of graph I want to make. It's a pair plot, and I already decided with the scattered plot, but I am just going to plot the regression. So there is no need of worrying about warnings, maybe we hide. Yeah, so this is actually our regression plot. So the TV, the sales, and the radio, and again the sales difference, and the newspaper, again the sales difference. So whatever data we are implementing, that much of sales, like how much the linear lines. So when we are observing this TV, so let's we observe, we have actually strong relationship between TV ads and the sales. Yeah, when we are having the sales is also increasing, the TV ad also increasing, the sales also increasing. It's not in radio, we doesn't have that much of response, and when we are just choosing our newspaper, sometimes we are having good sales, and sometimes here we are not having a very good sale. So comparatively in this 3 graph, our TV ad is giving us more relationship between our sales, and for radio and newspaper we don't have that much relationship between our sales and the ad. So the next thing is, now we need to discuss about our linear regression advantage and disadvantage. So when we are choosing this linear regression, it is a fast, and it's a high interpretable, and it's easily understood. So when we are choosing a predictive accuracy, the linear regression between the future and the response, it performs little less, and the relationship is highly non-linear in many scenarios. So this linear relationship will not effectively model our relationship, and we can't able to make this as a very good prediction. So these are some disadvantages. So when we are going to form a linear regression, then we need to make something like intercept coefficient of our data. That is nothing but y is equal to b0 plus b1 x. So for example, y is equal to, I am just giving a b, so 0, and then we need to make something like b1, yeah, and then x1, and again I am just giving is plus b2, and then again I am giving a x2, and this is like continuous, so bn, and again I am giving an xn. So once we make this, our next step is, here we need to apply the response. So now here I am just telling y is the response, and this b0, it's our intercept. So here b1 is a coefficient for our x1, and b2 is a coefficient for our x2. So like this, our b values, from b1 to b2, bn values will vary. So here x1 to xn is nothing but our coefficient value, that dependent data. So now we are just going to make the relationship between our B0, B1 and our x's. So here we are just going to make link this scenario with our example. So so I am just making y equal, so B0 is the intercept, so let it be, so plus B1, it's a coefficient, so for here TV, yes, so into TV, and then what we are just going to make here is nothing but our next coefficient B2. So this B2 is a coefficient for our radio, and again our B3 is our coefficient for our newspaper. So again we are just giving newspaper. So this is actual our formula which is actually related with our model. So in this values we are learning, when we are planning to fitting the step, we need to use the least square criteria. Then we need to go ahead with our fitted model, which can be able to make the right prediction or not. Okay, so now this is actual formula which we are planning to apply. So now we need to prepare our x and y. So x is our future matrix and y is our response vector. When we are just making in our numpy array, and when we are just going to make in our pandas, though x is our matrix and y is our panda series, that's nothing but our vector. So we make a variable name called future columns. Now I am planning to make a TV as 1, and again I am just making our radio, and then again I am making our newspaper. Great. So these three things we decided as a future column. Now I am going to make our x variable name. So this x I am going to apply the indexing of our data, that is nothing but the original data set which we read to our future column. So now our x is the list which is the selected subset of our original data frame. So now we need to command one line. We can able to do like this, else we can able to do in other ways. So for example, x is equal to data. So now we need to make a 2 data frames. So we need to make the same futures here. So this is another way to create our x. So now we are already having our x. So I am just planning to read the head. Great. We are having only the TV, radio, newspaper, and this is nothing but our default index. So if we don't want this index, we can able to make as index equal to true, so it won't comes. So our next thing is, now I want to check the shape of my x. So x dot shape, where we need 200 rows and 3 columns. Great. Now the same like I am going to make for my y. So for sales we are making as a y. Great. We can able to make our data like this. Okay, we just get a key error. So sales which I given is as a caps, it's a case sensitive. Yeah. Now we got the right answer. So we can able to make y like our panda series, else we can able to make like our SQL. So like this also we can able to make our y data set. So now I want to get the first 3 or first 5 of my head. So this all my y data. So now we get our x data, the same we are having our y data. So we check the shape of our y. So how much it's there? 200 comma 1, that's nothing but our 1 column, always row comma column. So now we are going to apply our pre-processing step. So for that I am just going to import my Sklearn dot model underscore selection. I am going to import our training and testing split. So train underscore test underscore split. Great. So now this is a small s, so it's running. So parallelly we will making x underscore train comma x underscore test, because we need to make a 4 training and testing, 2 for our x and 2 for our y. Always we are applying our linear model or logistic, whatever machine learning model, with our training, and the final output we used to evaluate with our testing model by comparing our models. So now I am applying the split. So now x comma y comma we need to give the test size. So why we need to give the test size? So why we need to give the test size? That's nothing but this much amount will be taken as our testing data set. So test underscore size equal to, I am planning to make a 25% of my testing, so I am giving 0.25. So now we are applying our random underscore state, which is used to make every time the same values will be getting as my training and testing. So great. Now we just get our training and testing, all those things. So let's we print our shape of our train. So to understand how much all those things is defined. So 150 comma 3, this is nothing but our training data set. Great. So now we will make the same thing for our test, 50 comma 3. How it's coming, like our x train and y train, which was already splitted. Our total data is 200. We make 25% of the testing data. So 25% of data, it's 50%. 50 data will be considered as a testing, and 150 data which is considered as a training. Great. So our next thing is we need to make, let's we check for our y test also. So first we will be making this for y underscore train. We are having 150 again, the same amount of data, because we are just applying the same level for our training and testing. Perfect. So our training of x and our training of y, testing of our x and y, actually which is in the perfect ratio. So always our testing data, it should be lesser than our training data. So now we are going to apply our linear regression in our Sklearn. So this is our next step. So to import our linear regression, first step we need to import our linear regression model from our Sklearn. So now I am making a linear underscore model. I am going to import my linear regression. So from our linear model library, I am importing my linear regression. So we are just running this. So the next thing is I am just going to initiate my linear regression. So for that perspective, I am making some variable name like regression, reg. Then I am going to make my linear regression as my initialized value. Yeah, here the spelling mistake. Great. So now we got our initialized variable name, that is nothing but reg. So now this reg I am going to fit with my training and testing model. So x train comma y train. So now I am just going to fit with my training data. So to learn the coefficient. Great. So now we are just getting our this intercept is fit, and then we didn't apply the normalized, and the linear regression model is actually applied with our training data set. So now we need to interpret our coefficient. So now I am going to print my coefficient value and intercept value. So intercept double underscore is the inbuilt function to get our intercept value. Okay, so we are getting an error. That's nothing but our linear regression which is not having the attribute of intercept. So probably we are making some spelling mistake or some errors. So what mistakes? Yeah, so here we need to give one single underscore, but unfortunately I gave double underscore. That's an attribute error. So here the attribute error, that is nothing but the inbuilt function which is not available with the particular framework or model. Great. So now we got the intercept value of our linear regression. Now we'll apply the same thing for our coefficient. So I am just applying my coefficient value. So great. So this 3 coefficient, that is nothing but for our x data. So now we need to pair the future names with our coefficient to remember the order. So we are just making the zip function to pair our future names with the particular coefficient. So when we are applying the zip function, zip is nothing but our inbuilt function which is used to make a compressed stuff. So here we have the column names like future columns. So now I am just copying this. Now I am just going to make a compressed folder for my future columns and my regression coefficient. So now I am just running this. Great. Now the zip is actually done. So probably we are having our coefficient value, that's nothing but 0.0466 for our TV, and our coefficient value, this is for our radio and this is for our unit. So when we are planning to intercept the TV coefficient for a given amount of radio and newspaper ad spending, a unit increasing in TV ad spending is associated with 0.044416 like this. For more clearly, for a given amount of radio and newspaper ad spending, we need to spend additional $1,000. So which is used to increase the sale for 46.6 times. So comparatively, we are having the better result in our TV. So in this statement, this is a prediction, not the assurance. If we are increasing a TV ad spending which is associated with it may be give a negative value or it may be give a positive value. So now we need to analyze our evaluation. So to analyze this evaluation, we need to apply the prediction. So again I am just giving another variable name of y prediction. So the variable name dot predict. So our value, which is nothing but this regression, that's nothing but our linear regression, and we already fit this. Now I am going to apply this evaluation model with my testing data. So now we apply the evaluation models to compare our prediction with our actual value. So now the model evaluation matrix for our regression, which is used to make the accuracy, instead of comparing the continuous value, we are just going to apply the matrices to check our mean squared error. So let me make that. So I am just going to handle the mean squared error. We first will go with mean absolute error. So what is mean absolute error? It's nothing but the mean of the absolute value of the errors. So where we are having actual value is equal to 100, 50, 30, 20. And now you predicted like this 90, 50, 50, 30. So now here what is the difference between 100 and 90 is 10, and 50 and 50 is 0, and 30 and 50 is 20, and 20 and 30 is 10. So this difference we are going to handle. So how to handle it by hand? So I am just going to make, so print of, so what is the first difference here? We are making 10 and then again 0 and then again 20 and then again 10. So we have 4n, that's nothing but a 4 numbers. So this is actually our mean square value. So how to handle this mean square value in our Python? So for that perspective, first we need to import the module from our Sklearn. I am just import the matrix and I am going to apply my mean square value from my matrix. So for that, mean absolute underscore error. So this is actually the inbuilt function which is used to handle our mean absolute error. So now we just printed this, but actually we are not applying this with any of my variable name. That's why I got output like this. So now I am going to make this between these two variables. So AC, that's nothing but the actual value, and a prediction value. So let's we apply this 10. So the hand calculation value and our matrix value is actually equal. So the next thing we need to cover is mean squared error. It's nothing but mean of our squared error. That's what our mean squared error is. So how to do this? Let's we do this by hand first. So let's we make some arrays by using our NumPy. So I am creating a NumPy. So now again I am just going to print some arrays. So it's a mean squared error. So this square 2. So this time that is nothing but the error, whatever that variance here. So again plus 0 square 2, again plus, again 20 squared 2, and then again 10 the power of 2. So again we need to do the calculation by 4. So our mean squared error is 150 in handy. So now I am applying our matrix function here. So print matrix. I want to calculate mean squared error. So mean underscore squared underscore error for the variables our actual value and our predicted value. 150, which is equal. Great. So the next thing is root mean squared error. That is nothing but the square root of the mean of our squared errors. So the total square root of this we are going to apply here. So where we already imported the NumPy. So I am just going to again give the same thing by adding the square root. So now again what we need to given here, that's nothing but 10 the power of 2, again 0 the square root of exponents 2, then again 20 and then again we are applying with our 10, so divided by 4. So now our output is 12.24 something. Let's we apply the same thing with our Scikit-Learn. So now I am going to apply, it's a square root, so I am just applying the square root. So matrix dot mean underscore square underscore error. Error. So now I am applying this to my two variable names. Great. So we are getting the same answer. So this is what actually our matrix, that's nothing but the model evaluation is. So now the mean absolute error is easiest to understand because it's the average error, and the mean squared error is the most popular than mean absolute error, because MSE, that's nothing but a mean squared error, punishes a large errors. This root mean squared error, the last type, which is even more popular than our mean squared error, because this root mean squared error is interpretable in the y units and it's easier to put all the contours together. So Now we are going to compute the RMSE for our sales prediction. So we are going to print numpy dot square root, and we are just going to apply our mean squared error. So mean underscore squared underscore error for our y test, that's nothing but our actual data which we didn't apply, and our y prediction, whatever the prediction we handled here. So we are having some values like 2.0. So our mean squared error, root mean squared error for our model is nothing but 2.0. So when we want to do some future scalar, like for example, now you want to do some modification. So either you are planning to remove your radio or newspaper from your data, and when we are planning to apply our RMSE, we will get some different error. So the RMSE will decrease when we are removing some other feature from this model. The error when we are minimizing, so the lower number of RMSE will give the better result. So when we are predicting the sale, if we are giving the lower number of RMSE, it's actually the better output. And to make a better future output, we used to remove some future from our data, which is nothing but a future selection. So this is a very basic thing about our linear regression. Here we are choosing a linear regression because the data which we are having is a continuous data.